Finally, we look at an example of a composite function, y equals e to the x squared. This is a function where x is first squared, and then we take the result and do e to that power. Okay? That means that y is of the form f of g of x, where g of x is the first thing that happens to x, that is, g of x is x squared. F of x is the next thing, which is e to the x. Now f of g of x is going to be what? If f of x is e to the x, then f of g of x is e to the g of x. And e to the g of x is what? E to the x squared. So we see that f of g of x is e to the x squared, and that we do have this composite. Looking at another example of a composite, y equals 2x minus 4 quantity squared. Okay. First thing that happens to x is we put it into the 2x minus 4 function, so that our g of x, our first thing that happens to x, is 2x minus 4. And our f of g of x is therefore, well, let's back up. G of x is 2x minus 4. We then square the 2x minus 4, so our next function, f of x, is going to be the squaring function. It follows then, since f of x is x squared, that f of g of x will be g of x squared. And if g of x is then 2x minus 4, g of x squared is 2x minus 4 quantity squared. And this ability to recognize composite functions is extremely important in applications, and especially when and if you take a calculus class.